This is a question a student asked me. This is a mini exam problem, and the student is saying that with this mini exam below, VB positive sequence angle giving is plus 20 or minus 120. If it is minus 120, y is 0. When you add them, shouldn't it be minus 240? Um, how do you solve positive sequence VB1 to get the positive sequence VA1? So it's a loaded question. And as I've been telling you guys in the past, sometimes just by looking at how a question is asked, you can get an idea of what are those, cracks in understanding, right? So, yeah, first of all, how do you identify this problem as? This is right from the top, it is a problem dealing with symmetrical components, correct? Now, guys, when we are using symmetrical components, what's our reason? What's the primary motivation for using symmetrical components? To figure out the voltage and current quantities in an unbalanced system. That's the key. Chris, you're right. Unbalanced system. Now, this neat and tidy arrangement of 120 phase shifts between phases and the line-to-line voltages holds true for what? The 120 neat and tidy phase shift balanced, correct? Okay. Now you look at this question when the student is saying, with this mini exam below, VB positive sequence angle given is plus 120 or minus 120. If it is minus 120, y is 0. Can you now dissect the gap in understanding? Because the student is forcing a balanced scenario on an inherently balanced system. He was expecting a neat and clean 120-degree phase shift between A and B. Well, if it was a neat and clean 120-degree phase shift, and over here, as you can see, even the magnitudes are off, so it's not a balanced system. But let's assume for a second that somehow the magnitudes were matching up. And then he's looking at 180, 0, and 90, and then pulling up the calculator. 180 minus 0 is equal to 180, right? So where's a 120? And then I do a 90 minus 0. So that's again not equal to 120, right? Well, you're missing the point, correct? The reason is that it's not a balanced system. A balanced system will never have positive, negative, and zero sequence components, all three. If it is an ABC sequence, which of these three components will a balanced system have? If I have an ABC system and I tell you that my system is balanced, which one will it have? Positive, negative, or zero? ABC will have a positive. It's positive sequence. If I tell you that I have an ACB sequence like in Texas, which one of these three will it have? Negative. And if I tell you that I have a system like this, which has non-zero positive, non-zero negative, and non-zero zero component, what is the bare minimum detail that you can provide me about that system without lifting your pen? That the system is unbalanced. Okay. So when you revisit this question, then you realize that, okay, the student is not approaching it properly. The right approach, I've explained this in the solution. You are given the sequence components. The question is asking you very simply the phase values. You're going to use a matrix. You're going to use the operator A. Everything is provided in the reference handbook, and basically go ahead and make the conversion. And don't expect that when you calculate VA, VB, and VC, it's going to be all very nicely, neatly separated by 120, because you're not starting out with a balanced system. Okay? Is that clear, guys? So from a conceptual understanding, I can very easily create even a question like this without even giving you numbers. I know students, you know, like to use the calculators, right? Like to work with numbers, right? And it's easy to sort of create a scenario with numbers in every single case and make you feel good by giving you some problems just to plug and chug. But if you are not systematically thinking through a problem, right, and having that conceptual understanding, it's not a good place to be. All right. So my response to the student is that this is an unbalanced system because it contains all sequence components. We don't expect the phase voltages to maintain 120-degree phase shift and ABC or ACB sequence, right? I explained you the deal with the ABC and ACB. Please note that sequence voltages are provided and phase voltages are being asked. And in order to convert, going from a VB1 to VA1, phase A to phase B, positive or negative, you have to use the A operator. And I've gone through several practice problems examples in the coursework explaining you that if you're given a phase A positive sequence quantity, by using the A operator, you can actually figure out the phase B positive sequence and phase C positive sequence and so on. Similarly, if you're given the phase A negative sequence, so if you're given phase A positive sequence, that is all you need in order to calculate phase B positive sequence and phase C positive sequence, correct? If you're given phase A negative sequence, you can calculate phase B negative sequence and phase C negative sequence by making use of the A operator, okay? And as far as the zero sequence are concerned, they are always equal, okay? It would still be a question. It would still be balanced if it had both positive and negative sequence, or does this? No. If you have both positive and negative, it's no longer balanced. Okay, for it to be balanced as a ABC sequence, it just needs a positive sequence. Okay, for it to be balanced as a negative sequence ACB, it should have the 0 and the positive sequence 0. And if you want to learn more about preparation of FE Electrical and Computer exam and the P-Power exam, then check out these playlists over here. Thanks for watching, and I'll see you soon in the next video.